Greetings everyone, my name is Akili Molly and today I will be presenting my experiment, the purification of chemicalized water, and I'm going to be showing you the simple scientific method and the different steps to an experiment and the different steps to my experiment. So let's get started. Alright, so first on the list we have your research topic. Your research topic is like the very first thing that you should find out when you're doing a research or an experiment. That's the first thing that is on your list. That's the first thing you're going to be talking about. So let's say your research topic is why bees pollinate, or why everyone buys $100,000 houses, or whatever your research topic is. That's what you're going to be researching on. And then next is your research question. I'm going to give an example of my research question so maybe you can get a better picture. My research question is, what type of chemicals and minerals are in our daily drinking water? And as you can see, my topic is the purification of chemicalized water. So of course my research question is going to have something to do with my topic. Make sure your research question and your research topic match, because if they don't match, people can get confused while they're trying out your experiment. Okay, so the next is your independent variables and your dependent variables. Your independent variable is a variable that does not change. It's always constant. Like my independent variable might be the levels of minerals in water. That will not change because when you are drinking water, when you are taking in H2O, there are certain compounds in the water that our body needs, maybe like electrolytes or oxygen. Those compounds will never, ever change. So that would be one independent variable. A dependent variable is a constant that does change. So, and it's kind of like observing. It's like an observation. So that's a dependent variable. Then you have your prediction. And a prediction is to predict. So you're supposed to really get a feel of your experiment and be like, what would happen since my independent variable is this? Since my independent variable is A, and my dependent variable is B, my research question is this. What do I think will happen if, this happens? Or let's say, to get a clear picture, let's say tomorrow is going to be sunny, right? And it's summertime. And it's just rained for a bunch of days. That's our dependent variable. That's changing. It's observing. We're observing. It's been raining for 5 days. Let's say it's been raining for 5 days. And then the next day, it's sunny. And then it rains another 5 days. The next day is sunny. Next week, it rains for another 5 days. So I'll predict, well, since it has rained for 5 days, that means it'll probably be sunny tomorrow. See, there's a pattern. A prediction is like a pattern. And you really have to pay close attention because sometimes it can be a little bit confusing. So that's your prediction. Then you have your hypothesis. Of course. And my hypothesis, for example, is depending on where you get your water from, that's how you can determine what chemicals and minerals are in it. And that is definitely true. If in my experiment, I'm going to be comparing and contrasting different types of waters: rainwater, bottled water, tap water, and I'm going to be saying, okay, so I predict this, or this is my independent variable, this is my hypothesis for each experiment each time. So it's really fun and it's really simple. Of course, your background research. Now, for my experiment, I actually started doing a experimental paper, or a research paper, and my introduction. that is exactly what your experiment is going to be based on, is your background research. Because if you don't know anything about your research topic, you can't have a research question. If you don't know anything about your research question, you don't have background research or independent variable, dependent prediction, hypothesis, nothing. So all of these components are very, very important. And then next is your procedure, which is like the directions of the experiment. You're going to be guiding whoever wants to take on the challenge of purifying chemicalized water. They're going to be reading it. So you have to make sure it makes sense. That's why your background research is so very important. It's very crucial. And also, finally, I added this on because I thought that it was important, but you don't have to do this. This is very optional. What are the pros and cons of the main issue in your experiment? So my experiment is, of course, purifying chemicalized water, right? So the pros of that is like, oh, I know what I'm drinking. I know that this can benefit me in health, all my health issues. Let's say you have health issues. I have more information now. I am more clear on what brands to get. And the cons might be, oh, now I've been drinking all of this water. I had no idea that I was doing it. And sometimes pros and cons can help with your hypothesis. I found sometimes they can help with your prediction. It really just depends on your experiment. So that point is completely optional, but let's move on. So my experiment, of course, I said I was experimenting on tap water, bottled water, and rainwater. And of course, if I'm going to be using a purifying kit, like a water purifying kit, you're going to be like, okay, so what chemicals are you looking for, Keely? Well, I'm looking for lead, chlorine, fluoride, and BPA. Now, I'm pretty sure that the water I drink does not have lead in it, but it might have fluorine, fluoride, BPA, maybe some bottled waters might have BPA. You really never know. And those are the four that I really have familiarized with. So that's why I felt like I wanted to do that. So yeah. And finally, testing it out. This is the part that gets exciting, right, guys? So you're gonna need a lab notebook. You could have a digital lab notebook. You could have a composition notebook. Right here I have my picture next to me. You can have pretty much any notebook, I guess. And I even use a data table. Data table is getting all your information from your background research, whether it's mathematical data, whether it's scientific data, whether it's like really important notes that you took from a video. I put it in my data table. And I also put my components in my experiment into my data table. So I won't forget anything, and I'll know exactly what I'm doing. I also have a data analysis, which is the exact same thing as a data table, except it's mathematical and you use like different numbers. Sometimes there's like decimals and stuff. So you could use a data analysis. And make sure that you record everything down in your notebook. I remember Anna Erica, she was telling us to make sure you write literally every page number in your composition notebook. Write your name, write the date, write your experiment out, put your data table in it, put your hypothesis, everything you need in your notebook. So let's say you're doing it at the park or something. You'll have your notebook with you. Or let's say you are in the middle of somewhere and you brought your laptop. Well, you have your digital notebook. So it's always convenient to have your notebook with you or some type of electronic with you. So you can always be writing the things you need down. And of course, last but not least, materials. Materials are very important because if I do not have my materials, like my water testing kit, for my water testing experiment, what am I going to test? So you always need materials, you need prices, especially if you're not paying for them. Your parents will be. So you need to talk to your parents all the time. Transparency is awesome. And thank you guys for watching so very much. If you have any questions or comments, you can email me at ariane@gmail.com. And you can also ask any questions and post any comments you have